PreCalc, PreCalc, PreCalc. Here we are, back into the swing of things, hopefully. It is Monday, November 28th, and we're looking at what to do if you don't have a pair. So have you been wrestling with that? Sometimes you have a triangle and you need to solve the triangle, but you also have not a pair. You don't have any angle on the side opposite it. So let's just give you the general basic old triangle. So little a across from angle A, little b, little c. So here we have an oblique, which is a non-right triangle. And we're going to go ahead and make a principle to use when we don't know a pair. And it's going to be called the law of cosines. So to do that, I am going to make a right triangle inside of my non-right triangle by dropping an altitude from angle C to the side opposite. This is meeting the base at right angles, indicated by the little marking there. Let's call that K. And now I'll call this, if this whole side is C, and I want just this segment of the base, call it X, then do you see that this section is this section, C minus X. C minus X. Alright, so mark a triangle, draw and mark a triangle like that. Now, I'm going to see that Pythagorean relationship exists on both sides, or on this triangle. I'll take this triangle first. So, I'm going to make the Pythagorean Theorem, use that with the sides of this right triangle. So, it's going to be k squared plus c minus x quantity squared equals b squared. Alright, and when I write that, I can simplify it in a minute. So I'm just going to leave that like that. And then, well, no, I am going to solve for k squared. K squared equals b squared minus c minus x squared. Alright, so keep that in mind right there. And now I'm going to look at this side of the triangle and use Pythagorean relationships there, where I get k squared plus x squared equals a squared. Alright, so I solve that for k squared. And I'm going to get k squared equals a squared minus x squared. Alright, with that in mind, I see that k squared equals this, and k squared equals this. So here it is, right here. So I want this line and this line. Both of them tell me that k squared is equal to an algebraic expression. So I'm going to set those two algebraic expressions equal, because they both equal k squared. So I'm going to take the one from this line, which is b squared minus c minus x quantity squared, and then the one from this line, a squared minus x squared. Alright, let's simplify that and see what we can get. B squared minus, when I expand this, I get c squared. Remember, c minus x quantity squared is not c squared minus x squared. No, it's not a no-no, it's a no. So recall, it means c minus x times c minus x. Alright, you should have come to me knowing that, and it is c squared minus 2cx plus x squared. And this negative sign will come out and change everything behind it. So I will take care of that now. Alright, so I changed the signs. And that equals on this side a squared minus x squared. Alright, let's go ahead and let's solve that from one of the sides. Let's solve it for b squared. So b squared equals I move everything over, I'm going to get c squared x squared. When I move this term over and this term over, there's already an a squared and a minus x squared and a 2cx. Oops, that became minus when I moved it over. So the x squareds cancel out. And so I have left a c squared plus an a squared minus a 2cx. However, if I'm trying to use this as a formula to find an unknown side, I do not want to work with the inside value of x, because in a problem that's not given to me. So I want to mess with the x. Let's use an expression that would help us. So I'm going to recognize that there's a relationship between x and the cosine of b. So if I come from this angle and I use the cosine of b, what does the cosine of b equal? The cosine of b is side adjacent divided by hypotenuse, x over a. So I can solve that for x and get a cosine b. So let me write that over in this expression. Where there was an x, I'm going to put in an a cosine b. Very good. Let's clean it all up and see if there's just enough room to put this on. B squared equals a squared plus c squared minus 2ac cosine b. Alright, I'm not sure that showed up. Let me circle it and see if I can, or square it, rectangularize it, see if it's there. Alright, let me write it up top so you can see it in better form if it came off the screen. B squared equals a squared plus c squared minus 2ac cosine b. That might have went off the screen as well. Oh well. I will check and see. Now there are two other forms of that expression, and they are, without going through the derivation again from each angle, I will just explain to you and you can confirm for yourself. That's when you need to find side B. But if you were looking for side C, here's where all the expressions, c squared equals b squared plus c squared. C squared equals b squared plus a squared. Notice the pattern here I'm following. B squared equals a squared plus c squared. Now I have c squared equals a squared plus b squared. Usually written a first, so I'll do the same. Minus 2, this time ab cosine c. So looking at the patterns, you can see that whatever side is squared on this side of the equal sign matches the angle in the cosine expression on this side. Notice whatever side is on this side, the other two are added on this side. And here we see remnants of the Pythagorean Theorem right there. So let's see if you can come up with side a squared is. Following the pattern, go ahead and I'll count to 10. Alright, you should have it. Following the pattern, a squared equals b squared plus c squared. And we have a minus 2bc cosine a. Alright, there's the law of sines, and in the next section, I'm going to check and see if this showed up on the screen. And in the next section, I'll go ahead and explain how to do one in a problem. So I'll be right back. Be back for part 2.